So, today we're diving into a technology that is set to revolutionize how we think about blockchain interoperability, and that is Wormhole Queries. It gives you on-demand access to multi-chain data, leveraging the full power of the Wormhole Network. The way I like to think about it is if you imagine the internet without APIs, that's essentially where we are with blockchain technology today. Each chain is an island, rich with data, but somewhat isolated. So the question that we think about in interoperability is, what if we can build bridges between these islands and allow the data to flow freely and securely? And that is exactly what Wormhole Queries aims to achieve. So before we dive in, I'm going to consider some of the high-level wormhole architecture introduction and give you guys the basis for then the motivation behind why we built queries. And then I would love to go into the technical architecture and then show you guys some demos. But before that, I'm going to discuss the state of interop today and how we at Wormhole think about that. So just as fiber optics connect our global internet, allowing instant comms across continents, Wormhole aims to connect blockchains. We are building the digital infrastructure for the next gen of the internet, and this is one that spans multiple networks. The number of active chains in the last decade has actually exploded also. We see now hundreds of chains, and you've got rollups, you've got layer 2s, you've got based rollups, you've got ZK rollups, you have all flavors, you have EVMs, SVMs, and over the past decade now, we've seen a massive explosion in that number. And each of these chains offers its own unique features, but they often operate in isolation. So we really obviously want to think about how we bridge these ecosystems, but they all speak different languages, essentially. That is where Wormhole as a network comes in. So as a network, we connect 36 blockchains, it is, I believe now, spanning over 6 runtimes, supporting over 200 applications with thousands of other tokens and other bits of infrastructure using the Wormhole network permissionlessly to connect between these two chains. And this means we're sort of not just theorizing about interoperability, but we're actively enabling it across the majority of the blockchain ecosystem today. So again, the number of chains that we've all heard of is now in the hundreds at the very least. And when building these solutions, we like to prioritize 5 areas: security to protect assets and data, decentralization to avoid single points of failure, UX to ensure adoption, and open source verifiable code for transparency and trust, with scalability to handle the growing demand. And you look at the DEX to SEX volume over time. For us, it's really a shift that I think we're all seeing. The trend really does underscore the growing importance for cross-chain liquidity and seamless asset transfers. So we try to position to facilitate this transition by enabling efficient cross-chain operations. And at its core, blockchain interoperability is about enabling isolated networks to communicate the data. So it's almost like creating a universal language that all chains can understand and use to share information and value. In a way, it's just passing arbitrary bytes from one chain to another in a secure, trusted way. How do we do this? We do see it, of course, as not just a technical achievement and a catalyst for growth of chains, growth of protocols, growth of new users coming on board, removing barriers between chains, enhancing scalability by distributing load, increasing TVL by allowing assets to flow freely, and entirely new use cases that weren't possible in siloed environments. interoperability itself isn't a single layer solution either. And this is becoming more and more focused on, as we move away from focus on one level, the protocol layer ones and dApp interactions that we're all so used to, and focus on this kind of chain abstracted or intents based world. At the core of this stack is the messaging layer. There is another good framework, actually, which I will refer to. I'll give a shout out to the Cake framework, which I would recommend checking out as well. That was set up by the team at Frontier Research. So I can actually share that as a resource afterward. But the Cake framework is also another way to think about how to standardize the interoperability stack and what that might mean in terms of, all of these new terms that people have coming in, and fancy names for different fancy names for essentially sometimes what is more or less the same thing. So you will have heard this one as well, probably. We're all building the same thing at the end of the day. And you really want to think about what levels of the stack you want to operate on, what areas you'd like to own, what areas you'd like to dive into. So again, these are the key areas when we look at interoperability. Interoperability as an entire industry itself has also pushed the whole blockchain ecosystem forward in terms of things like security, for example, like being transparent with audits and audit reports. Interop protocols have the highest number of public audits. They also have the largest bug bounties out there as well. So it really is pushing the whole ecosystem forward in many ways, both from a technology, security, transparency, and auditability perspective, but also at the end, delivering the UX and scalability that we all really, really want to be able to use in order to build protocols that, have the impact that we all really want to be having when building. So again, Wormhole is one of the leading interop platforms powering multi-chain bridges and applications at scale. And it's actually facilitated over 1 billion cross-chain messages across 30 blockchains. So going strong so far, facilitating a lot of messaging, and what's in store for the future. So I'm going to dive into how the core protocol works, which is key for understanding then again the motivation behind why we built queries, and then I'm going to go focus deep on queries. I'm very excited to share with you all. So yep, here are Wormhole by the numbers again. We're actively enabling this, and our strength lies in decentralized development. So these are some of the chains that we support, and our strength really lies in the set of contributors from around the world, including significant contributions from Asia as well. The global collaboration really ensures diverse perspectives and really, really robust development across the board. So we have a set of core organizations as a decentralized protocol, all supporting us in the tech that we put out. And again, these are some of the key integrations that we have going. And I'll talk more at length about some of the queries integrations as well shortly. But we're very lucky to be working with some of the best across the space as well. And again, yes, Uniswap has just deployed its 7th governance deployment using Wormhole messaging. So again, just showing how robust the infrastructure really, really is. And again, this is why queries is so exciting, because it enables you to leverage the full trust assumptions of the Guardian network in a much more sort of innovative, I would say, way than traditional push messaging. There are plenty of use cases for the core messaging, of course. At the basis of it, as you all know, is passing arbitrary bytes between chains. So that can enable all sorts of use cases. I've listed a few out here, but there are many, many more that can be built on top of this type of infrastructure. And again, this chain abstraction is this kind of future that we're building toward. Users shouldn't need to worry about which blockchain they're interacting with. Through wallets, we're making these cross-chain interactions seamless and user-friendly. We're working very closely with protocols who focus heavily on chain abstraction. For example, Near, powering their gas abstraction. For the Near MPC chain abstraction setup, which is again very, very cool. Ultimately, the end user and ourselves as developers are trying to access what blockchains we want when we want without sacrificing security and user experience. And as I'll go into, there's now different ways to do that. So let's look at the anatomy of a traditional push message. Let's start to look into this very quickly. The VAAs are the core messaging primitive in the Wormhole ecosystem. They represent a message sent from some source chain and includes the details of the event and all of the guardian signatures. So there are 19 guardians in the Wormhole network as a proof of authority type network. Each one of them is responsible for independently signing and verifying each message that passes through the network. Each one of them runs a full node for every connected chain, so they can directly observe these messages. And between the guardians, there is our own network, which is called Wormhole Gateway, which is a CosmWasm implementation that enables a gossip network between the guardians, which we use for all sorts of things. Like we use it to enable what's called the governor feature on the wormhole, across the Wormhole transfer network. That's across both protocol level, so for example, chain-to-chain limits, daily limits, rate limits, and also can be configured per token. So for example, with NTT tokens that are enabled by native token transfers, which Nikhil showed you all last week, these governor limits can be enabled through that gossip network that they all share, which gives us all sorts of great efficiencies. And these rate limits can be set transparently. They can be per chain, inflows or outflows, and they can enable secure expansion to new chains as well with a very transparent process. So more on that later and why that's relevant to Wormhole Queries. The final aspect that you would need to know about in the core setup is the relayer, which is an off-chain component that executes the final part, the last mile delivery, basically, executing on-chain the transaction, delivering it to the destination chain, the signed VAA, with the action that needs to occur on the destination chain. It's then picked up by the relayer, an off-chain component, and is then delivered to the destination chain, where it's then verified against the Wormhole core contracts there. So right now, we have a decentralized set of relayers. There's different flavors of relayers. Client-side relaying can also be a thing where users relay their own transactions. But there's different flavors of relayers. You've got standard ones for EVM, all out of the box, specialized ones for Solana. So there is all types in there. And yeah, so Wormhole operates through this series of steps. It starts with a call to the core contract, which produces a log entry. And then the guardians notice and sign those messages, creating a VAA. When a supermajority of guardians, 13 out of 19, has signed this, the VAA can then be relayed to the target chain, where it's then verified and acted upon. And this all generally happens within a second, couple of seconds. So some of the team will say a second. I would tend towards more like that. So it is in the order of a second that all of this happens, which is fantastic. And then, of course, we just wait for the finality on the source chain, of course, before that can occur, and then it just gets emitted directly to the destination chain. So in terms of latency, it's very fast. It's very secure. And the foundational messaging protocol is actually the key to our interop solution. This is the general push messaging solution, guys, right? It allows for a secure transfer of arbitrary data between the chains, breaking down those barriers that would have traditionally confined applications to their native ecosystems. And here is a very basic breakdown on how that looks. And here is a more detailed breakdown on how this looks. So as you can see, a source contract will publish the message, passes through the core. It's then emitted, picked up by the Guardian network, all validated independently, aggregated into a VAA, picked up by a relayer, pushed to the destination chain by the relayer, and is then verified against the core contract where that action can then occur. Now let's dive into Wormhole Queries. So queries you can think of as enabling developers to efficiently retrieve and attest to cross-chain data on demand. It's a pull-based messaging service that opens up very, very exciting possibilities for real-time multi-chain applications. And queries enable a wide range of really, really powerful use cases, I'll say. This is actually, let's go, yes, sorry. So you've got from real-time cross-chain price feeds for DeFi, for on-chain feeds. This is highly relevant for liquid stake tokens or liquid restake tokens, where there might be some value that's constantly changing. Those can be then pulled directly on-chain. Cross-chain asset verification for gaming or for digital identity solutions. You could enable perps trading on a target chain without needing the user to actually bridge the assets over to that chain and just depositing them in a contract on their home chain, which you could then query. So I guess the challenge we face here is sort of like simple but profound, I would say. How do we access data from one blockchain while operating on another quickly and efficiently? Traditionally, if you wanted to use, say, Ethereum data on Solana, you'd need to deploy a special contract on Ethereum, make a transaction to push that data, wait for finality, and then finally use that data on Solana. This process is slow, expensive, and inflexible when it's just to query existing data on chain, right? So queries introduces a pull-based mechanism. Instead of pushing the data now between the chains, if it already exists there, we can just query it on demand. It's basically like a universal API for blockchain data. And you do get some benefits here. So it's sub-second latency on EVM and also very fast on Solana, where it's also integrated. It's up to an 84% gas cost reduction. So it can be almost an order of magnitude. The key also here is that you can batch queries. You can batch up to 255 queries into one call. So that results in a potential gas saving of a very large amount. It could be 1000x if you were batching that many calls together. And so rather than writing and deploying a contract on the source chain and having the contract monitor for specific state changes or events, what can happen is these queries can be triggered either by a user action or by a scheduled off-chain function, for example, like a Lambda. And at its core, this provides a mechanism for dApps to request information from any supported chain and receive a full attestation of that information from our network of guardians. It does make it much faster, cheaper, and more flexible than traditional communication methods. So at the heart of the network is the guardians. Try to zoom in here, but hopefully you all can see this. So again, each guardian runs a full node for multiple blockchains. It listens for query requests and then executes these queries against the appropriate blockchain. It's also enabled by this gossip network that I mentioned earlier, the Wormhole Gateway. When you need information from another chain, the Guardians fetch it for you, they verify it, and deliver it back. And this decentralized network of 19 Guardians ensures that no single point of failure exists and that the information provided has the full trust assumptions of the entire Wormhole network. So again, walking through this step by step. First step is query initiation. A dApp will send a query request. This could be anything from checking a token balance on Ethereum to verifying an NFT's metadata on Solana. The next step is the request validation. The system validates the request, checking that it's properly formatted and comes from an authorized source. The next step is the Guardian processing. The request is sent to the Guardian network, and each Guardian independently validates the request, executes the query against the appropriate blockchain, and signs the result with its private key. The next step is then the response aggregation, where the system collects responses from multiple Guardians, and then finally the consensus verification, where the system ensures that a quorum of Guardians have agreed on the result. So this consensus mechanism provides a very high degree of confidence in the accuracy of the data that's being received. Finally, the verified data is delivered to the dApp that was requesting, or the application, or the user, whatever event requested that, it's delivered back. And the entire process happens in seconds. Again, sub-second latency, which is a dramatic improvement over the traditional communication methods. So maybe if we dive into the architecture, maybe over here. Yes, okay, cool. So we'll dive into some of the architecture a little bit more deeply. So you have a query request format. The request is a carefully structured piece of data that includes a version identifier, a nonce for replay protection, the number of per-chain queries, the actual query data for each chain, and then the per-chain query structure specifies the target chain ID, the query type, the length of the data, and the actual query data. Coming back over here. So the Guardians use batch requests to minimize the RPC overhead. Like I mentioned, you can batch up to 255 requests together. And for certain query types, like ETH call with finality, Guardians will ensure the desired finality before returning the results back to you. And the response format includes the original query request for verification, the results of the query, and the signatures from the Guardian. So this architecture ensures that CCQ remains not only fast and efficient, but also secure and verifiable. And again, security is so paramount here that we have implemented some key security features with this all in mind. We use environment-specific signing prefixes to prevent replay attacks across different networks, which might be mainnet, testnet, and devnet. We provide DOS mitigation. We separate we have a separate P2P channel for all queries traffic. We have peer ID filtering to only allow communication from configured hosts, and invalid requests are dropped without response to prevent network spam and overloading. We also have allow listing, where only configured wallets are allowed to sign requests, which also prevents unauthorized queries and presents a DOS mitigation mechanism, which you'll hear more about in the coming quarter as well. Finally, for the REST endpoint, only requests with valid API keys are processed. This is also critical to note. This is that this is the current architecture, while Queries is in its final stages of beta until we open up permissionless access. But right now, if you would like to access mainnet, you would just message us and we will issue you a key. So again, on the consensus mechanism, multiple Guardians have to agree on the result before it's returned, which protects against individual node failures or compromises. And let's just talk about the use cases now for a sec. The possibilities opened up are pretty vast. These are some of the protocols using queries. I think we pushed out an announcement a couple of days ago about WorldCoin as well. So let's say DeFi. Imagine a lending protocol that can check collateral values across multiple blockchains in real time. With queries, you can have a single interface that displays the user's collateral from all chains, all updated in seconds. It's completely decentralized and trustless. Or for a game, you could picture a game where items from different networks can interact seamlessly. So a sword minted as an NFT on Ethereum could be used in a game running on Solana with its properties and ownership verified in real time. So you can do gating and users don't have to move any of these assets. Let's think about identity and reputation systems. You could use queries to enable a unified digital ID system that aggregates reputation data from various chains, which there are a couple of teams also working on this using Wormhole Queries. The user's identity can then be verified across multiple networks without the need for separate verification processes on each chain. And that can all happen trustlessly through queries, right? So you can think about it like a mega super RPC call where you're getting it done in a completely decentralized fashion. You're getting 19 separate attestations, you're getting those aggregated, and you're getting that with sub-second latency. Another one is a cross-chain DEX. So a DEX can use queries to provide real-time price and liquidity information from multiple chains to enable much more efficient cross-chain swaps. You could also think about even, say, supply chain, like real-world use cases. In a multi-chain supply chain situation, queries can be used to quickly verify the status of goods across different networks, each representing a different stage of the supply chain. So I really see these use cases as sort of just the beginning. And I really think of it as like a fundamental shift in how I think about blockchain interoperability. In the future, I would say, the actual cross-chain asset transfer part would only happen when balances need to be settled. So, you're really abstracting that away and you're pushing it like a little bit further down the stack, because you can just query those balances on the user's home chain, or you can have them lock collateral in a contract to then, let's say, trade perps on a different chain. So ultimately, that's the future that we really want to help enable with Wormhole Queries. So yeah, I see it as like a fundamental shift. And to give you guys an idea, actually, I don't have a slide that corresponds to this, to what I'm going to say, but to give you an idea, like we currently support all EVM networks that are connected by Wormhole, as well as Solana, but we are continuously working to add support for more chains to expand the reach and utility of the queries. And while the initial release focuses on off-chain queries, we are exploring ways to enable on-chain initiated queries to open up more possibilities for smart contract interactions. This is kind of prohibitively expensive though at the moment, and there's no like real need, because the proxy servers do have play a very, very trustless part in the whole shebang. So we are always looking for ways to optimize the process, but we also see new query types as potential new avenues for expansion. So we've got ETH calls, ETH call with finality, Solana account query requests, and Solana PDA query requests. Finally, yeah, we're always committed to making queries as developer friendly as possible, with ongoing work on the SDK, docs, and developer tools. So yeah, without further ado, let me jump in and show us all a couple of demos. And let me just come back and check here about any questions. Cool. I'll come back to the questions in a bit. Cool. So let's look at this very trivial demo of using queries to sync counters across EVM chains. Here we go. Let us check through the UI here. So here's a very simple UI that can show you the front end of how this is all constructed. I will initiate, so this is on the user side, a user initiated call. And this would be automated, of course, in the back. And you can see that the ARB count was just updated. You can see what it's querying. You can batch these requests. Of course, you can batch up to 255 requests together. Let's do a base call. Go same thing. We can check this out on chain. This is on the ARB chain. So there we go. There's the latest call here to update counters. It contains the info that I mentioned with the signatures and the response in there. Great. So you can see how that works with a bit of a UI. Here's also the optimism demo. And there you can see how that's all working successfully. Great. And you can see here what's being called to update counters. Perfect. So really there are a lot of possibilities here. And just looking in, you can see here to pull all, let's say, you can see here how it's constructed. So this is different from the push-pull demo because it requires each message to be redeemed in order based on finalized results, and the digest is stored per destination chain. The redemption hashes are similarly tracked. So again, this is like trying to maximally reduce gas costs for, let's say, a frequent messaging application. And this is a great example of how a query can be constructed. You can see here there's great notes from the team that's put this together. And this is a great example that a high frequency DeFi DApp could use in order to pull values from across different chains. So let's now also go into the example of the Solana stake pool. So we'll use a real life example here. Jito Sol, which has currently been initiated over on Arbitrum, is using Wormhole Queries to pull the real-time rates. They update their rates roughly every 24 hours. It's something like 48 hours for the rate to go stale. So 24 hours is like a good number for the Jito team to pull this. And you can see how it's constructed. It's an immutable query response processor. And updating the pool, again, the validation includes verifying the signatures, passing the response, includes 2 results. The response is for Solana. The commitment level is for finalized, so it's querying the finalized state of the Solana chain. It's not querying an instant result. It's going to be 0 in the configured stake pool account, and it's owned by the stake pool program. You then have the clock, the sysvar clock account in there as well. So this is how it might look to get rate. There's some documentation around testing if anyone is interested in Solana stake pool. And I can actually run that for us up here. Here's the demo. So you can see here that the current Jito Sol stake pool rate is, sorry, I'll just increase this a bit, is 1.1224, etc. And that's going to be, every time we query that, of course that updates every 48 hours. So that's going to be the same value again, and that is just queried directly on chain. We can see here the actual live calls coming through at this address. You can see here the mechanism, the update pool function by the Jito deployer. And if you decode the message, you should be able to see the response. And then you can see here there are all the Guardian signatures as well with the set index. So you can see here how that's pulled through. You can see all these separate signatures. You can see the response to update the pool, and that's all gone through successfully. So that's a great example of a Solana stake pool rate updating over onto EVM. Now let's also check out this example of using queries to check ownership of a Solana NFT over on an EVM chain. So you could also chain this with other queries, of course, to read program PDA, which can allow Solana wallets to designate an EVM address. You can also read the Metaplex metadata for the matching mint, or read anything that is stored in any account on Solana, which is really, really cool. You can query arbitrary Solana PDA or account data with Wormhole Queries, which is, I don't think anyone else has enabled anything like this in such a decentralized fashion. On the EVM side, of course, you can query arbitrary Solidity view functions as well. So you're not confined to just header proofs at the moment. But I'll touch on those in a little bit as well. But we see it as great because, of course, you can query arbitrary Solidity data with this as well. Again, you're not just confined to header proofs. So yeah, this is the verify owner result, which then, again, it emits this event here. You can try this yourself. It's very, very easy. You can fork test, so sort of local kind of devnet yourself, or again, you can reach out and to anyone here at Encode, please feel free to reach out. I'll give you details at the end, and then we can issue you testnet keys directly if you'd like to just test on the live testnet. So let me show you guys another example here. Let's query the chain link ETH to USD price. This is the last updated Chainlink ETH to USD price data. You can see here, this is a live call. I included the test API key there that I'm using, and just simple using Axios, and just pulling up this ETH-USD query TypeScript, which I will show you all so you can get a flavor of how this was constructed. So this is simply how it's constructed. Pulling in Axios, the Wormhole Query SDK. So using the SDK now to with Axios to pull a query. You've got the contract addresses, you've got the chain ID, so the correct chain ID on Sepolia. This is testnet. The reference here is constants. These are just some references, and I can actually share these examples as well after. I can share all these examples here that I've created. So again, this is how you'll construct your query. Response on data as an ETH call. You've got the past chain response. Put some timeout in there. It's not gonna necessarily happen, but just saves it. And yeah, you've got the decoded data. You want to show how you want to surface it. You can do whatever you want here, really. You can show this however you really want, but this is the key part. And then you can decode it however you want. Get blocked by number as the method. And yeah, this is not an ETH call with finality though, but yeah, just a live query of the Chainlink USD price feed, ETH to USD. And there we go. It's like the latest one based on the GMT time. But yeah, let's maybe dive into another test. Let's try a balance query. So we have just queried the balance of this address. We can see it's 2.244 ETH. That's the hexadecimal in a way. decimals. I had a note here just in case you didn't know. But let's check this out. Let's dive in under the hood here. So you can see here, very simple. Same import, same constants. Keeping it very simple. And then you've just got the address that you want to query a balance for. This could be anything, and you can get balance, latest block, give me the latest data, and there you have it. You get the balance. You can surface this obviously in any way, shape, or form that you want. So, for example, someone has deposited some funds into some contract, and you want to query like that particular transaction. That can be user like initiated, so that action can then initiate the query. You can then verify that the user has deposited funds into the like collateral or the the lockup contract. You can then credit their balance, let's say, on some other chain. So then let's say a user doesn't have to bridge assets from mainnet to Arbitrum, or they could even trade on a perps DEX on Solana, for example, without even having to bridge or to perform a cross-chain transfer of those assets. Again, that's a super exciting use case. So sort of multi-chain abstracted perps DEX or perps trading. Let's try the Sepolia query. So this is querying the price of USDC, I believe. No, this is just querying the USDC contract address. It's just pulling the name. You can see the number hash. Here are the signatures there. And then just diving into that one. You can see here how it's constructed. So some detail there. And then you're pulling, there's the results. You're getting the latest block number. And then you're pulling this response data of the name there. So that's your query response that you've got in there. And the past chain response. Let's try the Solana PDA demo. The way this is constructed as well, the Solana PDA demo, is actually, I'll show you, because this is a simulated event, I designed it to show some randomness. So let's simulate the verification process with a 50% chance of success for the demo purposes, so that you can see what an error might look like. Let's run it, and that was verified. So owner was verified. That's the account. These are the simulated signatures, for example. Let's try it again. That was successful. Another successful one. Another successful one. When are we going to run into an error? There we go. So again, this is just showing like what an error response might potentially be surfaced as. Again, you can surface anything here. So it's very, very, very composable, basically. It's a hugely composable system. So those are the demos that I put together, guys. The other one that I can show is I can talk through actual queries verification on Solana. These are, this is basically what like needs to happen. This is what we've done so far on this. I would recommend checking this demo out. You can check out the docs here as well. I'll show you guys as well how to reach out my side for requesting a testnet key for us. But the docs here really have, again, everything that you all should need. Explains the 5 types of queries that are supported, the ETH calls, and by timestamp, and with finality. The Sol accounts and the Sol PDAs. Again, we're actively looking at expanding to new chains. This is the chains that are supported right now. The expected history is, we're just keeping this on the very, very, very safe side. You should be able to query much longer than that. But as you can see, all the EVM chains that we support, there are a couple missing here that we've already enabled, including Mantle, Xlayer, Verachain Testnet as well. If you all are interested, those are all supported as well. I would recommend team checking out the down here. You can see the Wormhole constants reference. This explains the chain IDs that are used by Wormhole, which you'll need as well. They're different from the more commonly referenced chain IDs. So the Wormhole chain ID is separate, of course, to the standard, like ecosystem referred to chain IDs. So these are the test nets, the Sepolias down here. So you'll see, you've noticed in those query responses that we constructed, there was a couple of references to these chain IDs. And then to learn about the consistency levels at the end around finality, which is not super relevant for queries, but if you want an ETH call with finality, you can pull the 201 or just anything other than 200 or 201. Sorry. So ETH mainnet supports instant, which is 200 code, or safe, which is 201. And the details in here, like we just follow Alchemy or Circle. We've done our own testing as well. There are details of our own tests around these consistency levels. So again, that's an important thing to note. So then just going back to the queries docs, you can see how simple it is to get started. There is a very simple example here. This is how you would construct the queries. Again, there are the examples. I'll share the extra examples that I've done as well. And you can see here, it's just up to your imagination what you might want to query. You can batch, again, 255 together from separate chains, because it's enabled by that gossip network, as I mentioned, which runs between all the guardians. You can log this out as JSON to see the structure there. You can see the chain IDs, the nonce, query the call data, the type of data, the tag, the version. So you've sort of got it all in there. So again, ETH call is a standard EVM call. ETH call by timestamp is queries based on block timestamps. With finality is ensuring your desired finality before returning the results. Sol account is queries Solana account data. And Sol PDAs queries the Solana program derived addresses. So, we have a TypeScript library for building queries, an EVM response parsing library for smart contracts as well. So that's all sorted in there for you all. The SDK as well, which is fantastic. Highly recommend. And this is, if you test this all together, again, this is a great mock query response. This is a great example of what this might all look like. You can fork test as mentioned, but feel free to reach out directly and we can issue you a testnet key. These are the details that you'll need. And when you want to verify the query response on chain, we have an abstract contract that is we built to assist with verifying those responses. It does come down to these 3 steps. So pass and verify response. It handles the verifying of the signatures against the Guardian set stored in the core bridge contract on that chain. It validates the request details. So these could be different depending on your use case, but it will check, is the request against the expected chain, the expected type, is the resulting block number and time expected? Because some of you guys might require that a block number be higher than the last or be within the last 5 minutes. So you can validate that, the block number and the block time, to help with these checks to ensure that you're validating the right data on chain. Is it for the expected contract and function signature? So helping with these non-parameter dependent cases. It even checks the expected length, and there's expected result type. Finally, just ABI decoding the result. So again, you can check the demo contract for an example of this and check the doc strings of the above. So yeah, again, the query proxy query response result does require a slight tweak when submitting the contract to match the format of this, but there's a helper function, signatures to EVM struct, provided in the SDK to help with that. So this is how it might look like in the demo contract. Quickly, a couple of FAQs, I think. Yes, so as mentioned, the TypeScript SDK can be used to mock, create, and pass, along with some other utilities for posting them. The abstract contract can be used to pass and verify the responses on EVM. The Solana stake pool repo demo is very, very good. Here, the SDK has a query test contract as well, which you can check out for mocking the requests and responses. And lastly, there's the Go package as well. One thing I will mention is that we're working actively on the Rust SDK as well. Here's a link to a bunch of examples. I'll also share my ones. Finally, the format of the response signature is calculated as in the ECDSA. So that's what the digest hash looks like. If you have any further questions about that, again, please feel free to reach out. So coming back to here, I have a couple more slides. Excuse me. I just wanted to touch on the future for queries as well. This is some of the future, of course, as well as other things that we might be cooking up. But yeah, we've been working on ZK verification frameworks. This is very exciting because it will enable us to query proofs that are generated from certain chains, query them over to the connected chain, and it will mean that we're able to expand to certain chains, such as, let's say, Near and Aptos and Sui, where we're actively working on developing light clients and be able to query header data from the tip of those chains. So that is also very exciting. And that will be a mechanism that you would be able to select alongside the Guardian verified responses, which will always be there because they enable you to query arbitrary data rather than just headers. So it's like header proofs, you can query the state root or the consensus root. So yeah, I would say there's a bit more info here with a link, but I would say, yeah, the implications of the tech are profound. And I think it really does have the potential to revolutionize in how we interact with blockchain dApps and how we build them. And I think we're moving from a world of isolated blockchains or isolated islands to a sort of vast interconnected blockchain continent. So I think we're really standing at the threshold here of a new era. And this tool is something I'm particularly passionate about. So feel free to reach out to me and connect anytime. My Telegram is am_os, am_os, but I'll get that posted out to you with the other examples, and maybe I'll add it into these slides. But yeah, go. Hello.
Hello. Thank you so much. We've got a few questions.
Awesome.
The first one is, given that the docs say this is in closed beta, will these guys be able to use it in the upcoming Wormhole Hackathon?
Yes, 100%. So I would say it's a closed beta, but only because we haven't yet built permissionless access to mainnet. So it's 100% working in mainnet and uptime of 99.999 etc. percent. If you want to use it in a hackathon, please reach out to me directly. I'll issue you a testnet key, an unrestricted testnet key, which you can use. Go wild. Would love to see any queries implementations in any hackathons. I'll probably be following up with you guys directly if you make any submissions. So yeah, I'll chillax. I'll be able to, and Ocean Fan as well. Please just DM me, guys, with your use cases. feel free to DM me. My TG is right there. I can get you guys provisioned with testnet API keys. And again, like I mentioned, we're working on a DOS prevention mechanism for people to be able to access mainnet without an API key. But testnet will always be provisioned, and devnet, etc., is mock testing locally. So it should be very easy.
And then also we've got a question from Adam from a while ago, and he's asked about the general wormhole network. How are the trusted guardians selected? What are the requirements? And are you planning on having more, given you had that currently in brackets on your slide?
Yeah, for sure. So I'm not sure why I had that currently, because we've done a ton of testing and we found that 19 is the optimal number, because you need a supermajority to validate any request or make any upgrades, for example, to the core contracts. That governance process has to happen in a very transparent way, in an open forum. The guardians themselves are the likes of really large infrastructure providers or massively values aligned actors in the space. For example, Figment or Rockaway X or Chorus One or Triton. So these guys are all heavily aligned with, their incentives are heavily aligned with ensuring interoperability. Remember, they're all running a full node for every connected chain, so they have an incentive to, back every one of these networks and ensure proper free-flowing, secure and safe information. We've never had an issue with any of these. They're all doxed, reputable actors, some of the most reputable across the crypto space. For example, they're all completely doxed. And there's more info on the Wormhole Guardians. And there's also dashboards as well that I will be able to hang in here. So you'll be able to... So again, you'll have heard of lots of these guys like Football, 01 Node, P2P Validator, Staked, staking facilities, Sync Node, Staking Fund, Chain Node. I'll post that up in here. That's a bit of a dashboard. We are working on some upgraded dashboards. You can also check out, for example, if you do ever want to dig in, I'm sure Nikhil would have shared this, but you've got Wormhole Scan as well to dig into specific VAAs. You can see there the dApps and the breakdown. And again, yeah, those guardians are all doxed actors in the space. So we aren't planning to add more, basically, to a long-winded answer to the question. The guys have done a ton of testing, and that is the optimal number. So any more would start to degrade performance. 13 out of 19 is pretty significant when you consider other networks doing 2 of 2, other interop networks doing 2 of 2 out of the box, for example.
Great. Well, we're coming to the end of the session now, so we're out of time. Ozzy's Telegram is in the chat, so if you have any other questions, then you can contact him, or you can contact anyone at Encode, and we can get in contact, ask for any resources that you want links to. But otherwise, thank you, Ozzy, for giving us this session, and thank you everyone for coming. Have a nice evening, everyone, or afternoon, depending on where you are. Bye.
Amazing. Thanks, everyone. Ciao.